Now, one of the greatest discoveries of the last century in astronomy was the Galactic Redshift. And we have referred to it, I have referred to it dozens of times so far this semester. But let's talk very specifically about that. Early 1900s, an astronomer named Vesto Slipher at Lowell Observatory, Percival Lowell was the fellow who contributed a lot of money towards Pluto and, of course, began the Lowell Observatory. Slipher looked at the spectra of a lot of spiral galaxies, and almost all of them were Doppler shifted towards the red end of the spectrum. Now, just to make sure we're all on the same page, a source of light is going to give us an emission spectra, specifically, and the one we look at the most often is hydrogen, because hydrogen is the dominant element in all of the universe. If an object is moving away from us, the lights in that emission spectra are shifted. The colors are all there, but instead of being on a specific wavelength, that line is shifted towards the red end. If an object happens to be moving towards us, that same spectra is there, but those lines are shifted towards the blue end. Well, and Slipher found out that almost all galaxies are moving away from us. Edwin Hubble, the same gentleman who determined that Andromeda was a separate galaxy, separate and similar to our own Milky Way, Hubble found a relationship between how far things are redshifted and how far away those galaxies are from the Earth. This is one of the most amazing and fabulous tools astronomers have ever come up with, because what he found was this. If the spectral lines, again, most commonly for hydrogen, happen to be right here, and a galaxy was some distance away from us, that spectral line would be shifted somewhat towards the red end. But if the same galaxy was further away, you would end up with a bigger redshift. It would be moved over not just a little, it would be moved over a lot from where it normally would be. So there's a relationship between how far away and the distance of that hydrogen redshift. By doing this, astronomers found that everything was moving outward away from us. This is referred to as the redshift of galaxies. Galaxies are all moving outward, most of them, away from us. This gets mathematically explained a little bit later in something referred to as Hubble's law, and we will talk about Hubble's law. This was the first evidence that the universe actually is expanding, like the remnants of a long ago explosion. And this was also the beginning of this concept of the Big Bang, the idea that the universe began with a large explosion. So here's one of the weird and crazy things about the Doppler redshift. From our point of view here on Earth, it looks like all of these galaxies are moving away from us. Well, back to our very egotistical human brains, it looks like, once again, we are the center of the expansion, which means we are the center of the universe. Well, hopefully by now you're smart enough, and most of mankind is smart enough to know that's not true. You and I are not that important in the entire universe. I hate to break the news to you, but not on the cosmologic scale. So why in the world does it look like we are the center of the expansion of the entire universe? Here's the weird and crazy thing, and this is kind of hard to get your head around sometime. All of space and time itself are expanding. All of space, the whole thing. And that means that everywhere is the center of expansion. Now, we're going to mess around with this idea in lab, but let me try and explain this here. And this is a series of pictures actually from your textbook. Here's the idea. Let's say we pick one of these dots on the balloon, and I'm going to pick, I'm going to pick this dot right here. If I'm on this dot on the balloon and I measure the distance to each one of my surrounding dots, and at some later time, from that dot on the balloon, I measure the distance from my surrounding dots. If you can imagine that you are a little microscopic human standing on this balloon on one of those dots from the point of view of that observer, each one of these other dots would look like they're moving away from you. And as that balloon expanded further from your point of view, as the balloon got bigger and bigger, each one of these dots would look like it's moving away from us. Now, is that dot the center of expansion? No, not even close. The entire balloon is expanding. But from the point of view of someone standing on a dot, as the balloon blows up, the distances get further and further and further away, and the dots that are furthest away, I'm just changing colors here, the dots that are furthest away have a tendency to look like they are expanding faster. That's kind of weird and crazy. Let me give you another analogy. Here's the raisin bread analogy. I don't know if you've ever made bread from scratch or bread with yeast, but let's say you're making raisin bread and you've got variety of different raisins inside that loaf. All right, you put it in a proving oven for an hour or two and you let it rise. Here's what you find. The distance between any two raisins is going to increase because it's not the raisins that are getting bigger. The raisins themselves are not the thing that are getting bigger. It's the space between the raisins that are actually getting larger. Yeah, weird, huh? So what exactly is expanding? We say that the universe is expanding. So what is expanding? Well, we think it is the actual fabric of space and time. When I say fabric, it's not real fabric, but it's a word to try and make some sense out of something. It is the space between galaxies. So if we use the balloon analogy, the space between these individual galaxies is getting bigger and bigger and bigger as space-time itself expands. One of the questions that people ask all the time, and it is a really fabulous, legitimate question, is, okay, if we're expanding, what are we expanding into? And the answer is, we don't really know. It is suspected it's maybe another dimension, because remember, to really understand Einstein and relativity, you have to buy into the fact that there are more dimensions than the human brain and the human senses can make sense of. The other possibility is that space itself is being created as everything expands, so that we're not expanding into anything. The actual act of expanding is making more space-time. Here's the other thing that sometimes some television TV shows get wrong, science documentaries even get wrong. It's the space between galaxies that's expanding. It's not the space between individual atoms. It's not the distance between the planets in our solar system. It's not the distance between stars even in our own galaxy or stars in our local group, or galaxies in our local group. It is the actual space between galaxies that's expanding. So what that means is you are not getting bigger. You're not going to end up taller at the end of your life than you were at the beginning of your adulthood just due to cosmic expansion. The reason is there are other forces in nature, force of gravity, electromagnetic force, which is responsible for all chemical bonds, and those are strong enough to hold things together if things are at close range, like you are to the Earth, or as all of your atoms are within you. So we're just talking about the distances between galaxies. All right, that is going to end that Doppler Redshift thing. We're going to come back next and talk about how all of this has been used to determine the age of the universe. See you then.